Hi, I'm from Lisa Academy. Okay, welcome to my project. And here you are about to see what type of building foundation is the best. Here's how we will see. You see this thing right here? This is a base connected to a foundation. What we will do is attach the base and the foundation to the platform made of Play-Doh. The reason why we use Play-Doh is because it's compact like the dirt around many houses and because it's reusable. Once we place it in, we will push a little bit to see the resistance, and then we'll base it on a scale. The scale goes from 1 through 5. Now I'll show you what they actually mean. 1 means that's very weak. 2 means that it's weak. 3 means that's average. 4 means that it's strong. And 5 means that it's very strong. Now, this is the first foundation. As you can see, there are some wooden sticks with rings around them. These rings, I think the purpose of the rings was to hang on to the Play-Doh, so it has more strength. So now we will test this, and I will use the scale to see at what level this is. I would put this somewhere around 3.5. Now, for my second foundation, let me clear off this Play-Doh. We will take the rings off. And now we will test this. Now I'm gonna see it. I would put that somewhere around 3. Okay. Now, remember what I told you about? We're going to use the foundation attached to this base. Well, for numbers 3 and 4, really what we're just about to use is building. Because what it is we're going to see if the ground itself can serve as a good foundation. Now, we're about to do number 3, which is going to be to see if a hill serves as a good foundation. Of course, there's obviously going to be one strong side and then one weak side. Okay. Now I will test, and I'll tell you where this ranks in the scale. I would put this somewhere at around a 3. And now remember, this is the strong side. So, rid of this. And now I'll push it to tell you what's the power of the weak side. So, I would put the weak side somewhere between 2. Somewhere between 2, which means, now you remember from the scale, which means it's weak. Now, let's move on to foundations 5 and 6. Foundation 5 is when both of them are a little separated. Now, I'm going to push Foundation 5 to see how strong it is. I would put Foundation 5 as to somewhere as a 2. Now, to test Foundation 6, both of them go in opposite directions, one forward and one backward. Okay, and now I'll place them differently, and now I'll push it to see the strength. I would put this as to somewhere as 2. Now welcome to my science experiment. In the last video we skipped Foundation 4. So now I'm going to do this next video about Foundation 4. Now, Foundation 4 is a building emerged in Play-Doh. Like I said before, we use Play-Doh because it's like the compact dirt around houses. Now, as you can see, it's equally distributed along both sides, unlike number 3, which was one side was bigger, one side was smaller. So now I'm going to use the scale to determine how resilient the Foundation 3 is. Now let me begin. Now I would place this somewhere around the 3. So that's my results for Foundation 4. Bye. The scientific principle of this project is to see whether a foundation's grip on the ground or to the level it's supported by the ground. Will that affect its earthquake resiliency? Thank you, Lisa Academy.